Okay, this is part one, and this is going to be lesson 3, and it's systems of linear inequalities. So we're going to be taking a look at more than one graph, and we'll be taking a look at where the data fits in with both of them, and kind of describe how this is going to work. You've got an example here. You've got a nursery school that's giving afternoon that should say snacks to their students, and they can accommodate 50 students together, and some come in the morning and some come for a full day. So you have two kinds of students. So that tells you you're going to have two variables, x and y. Okay, they tell you that the morning snack cost $1 and the afternoon snack cost $2. So if you're a morning student, it's going to cost you $1 per day. And if you're an all-day student, it's going to cost you $1 for the morning and then $2 for the afternoon, so $3 per day. Okay, the weekly budget is $120 or less. Okay, how will this work? Okay, we'll have to describe some variables here and assign them. So let's make x be the number of morning students. Okay, and that means that y will be the number of all-day students. Okay, so we have to write an equation. Remember, it can only accommodate 50, so that if I add all my morning and all my all-day students, they have to be less than or equal to 50. They can be less, right? You could have 40. They can be equal, but they couldn't be more than. So that's why I'm writing it like this. Okay, equation 2 is going to talk about the money. So equation 2 is going to talk about the money. How do we describe this? Well, remember it cost $1 for every morning student. So if I took $1 and I multiplied it by all my morning students, that would tell me how much that would cost for lunches. And I took the $3 and I multiplied it by all my all-day students. That would tell me my cost for those all-day students. Both of those added together have to be less than $120. So in other words, 1x plus 3y is less than 120. If you don't understand that, pause the video and go back and watch that. This is talking about how to describe it with money. So if you don't understand equation 2, go back, rewind, and watch this. Okay, are there any restrictions on your variables? And we've already kind of touched on this. Sometimes you can't have values less than 0, or you can't have half values. Okay, let's take a look at x. X and y have to be more than 0 or equal to 0. You can't have negative students. So that's one restriction. So no negatives. The other restriction is when we list our fine-tuning, right? What is our fine-tuning here? Well, x and y, can you have half a student? No, I hope not. So your elements here is that they have to be whole numbers or integers. And the reason is you can't have a whole student, or so you can't have a part of a student. They have to be integers. So they both have to be greater than 0. So if you're graphing it, they would be above 0. Plus, they'd have to be at integers. So if you're graphing this, you wouldn't be shading in the whole region. You would just be talking about discrete values at whole numbers. Okay, so that is the restrictions. And really, to fine-tune this, a better answer here would be x and w are whole numbers that are positive. Okay, I'm going to stop the video there, and then we'll continue to part 2.